Welcome, Pre-Algebra, to your next video lesson. Today we will be looking at sections 4.7 and 4.8. It will be going over exponents and multiplication, and exponents and division. You need to pay close attention today because the math we will be doing is very simple, but once again, it is very different. Most likely you have not seen problems like this before in your math career. Since it is so different, it is vital that you pay close attention and write down any questions you might have. Let us begin. Alright, first we need to go over some pre-examples. These are examples that I will work out right here for you. We need to understand some things. Let's say you have something like 7 to the second power times 7 to the third power. If you were told to simplify this, basically make it simpler, and you were told to do so writing or using exponents, how would you write this? What would this be? What is x to the second times, 7 to the second times 7 to the third? Well, let's write it out and see what it looks like. Is not 7 to the second simply 7 times 7? This times symbol we'll put right there. Is 7 to the third not 7 times 7 times 7? It is. Well, now I have 7 times 7 times 7 times 7 times 7. What is this number now? If I write it using exponents, has it not changed into 7 to the fifth? Again, let us look at another example. Is 5 to the fourth, is it not simply 5 written down 4 times with a multiplication symbol between them? That multiplication symbol we put right here. Is 5 to the fifth not 5 written down 5 times with a multiplication symbol between them? Now I have 5 times 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 5. Eventually it seems to lose its meaning, doesn't it? Anyways, does that not simply change into, you could say that equals 5 to the ninth? Yes, you could indeed say that. Now, I would like to point out something. You do not have to write down 7 times 7 times 7 times 7 times 7 or all those 5s. Instead, here's what you can do. If you see a term, if the base is the same, you see how these two are the same bases? They have 7 and 7. And if you're multiplying them, you are allowed to add their exponents. You might be saying, what? Well, take a look. I have 7 to the second and 7 to the third. 7, that's a 2, that's a 3. Add those together. What do you get? 5. Hey, that's what we got. Take a look over here. I got a 4 and a 5. You do not change the base. The base must stay the same, okay? Kind of like when you add fractions. Remember, the denominator stays the same? Well, when you are multiplying with exponents, you end up adding the exponents and the base stays the same, okay? So you add the exponents and the base stays the same. Look, ta-da. If you want to, you can write it out like I did just here and then compress it back down. Or you could just learn that, well, if I got that and that, it's going to equal 5 to the ninth. Make sure you don't go and multiply 5 times 5 to get 25, because that's going to make your answer wrong, okay? And this is very important to know once we get onto the variables, which we're about to do. So for instance, let's do some with some more numbers real quick. Let's say I have 3 times 3 to the third. That does not become 9 to the third. And you might be thinking, well, I know I'm supposed to add the exponents, but there's no exponent. Well, if you don't see an exponent, what's understood to be there? It's a 1. So you end up with 3 to the fourth. If you don't understand, just write this out. You'd have 1 3 here. How many 3s would you have here? You'd have 3 more. So you'd have a total of 4 3's being multiplied together. You could simplify that to that. Oh, good point. Over here, we would end up with 2 to the 4th power, okay? Here's some variables for us to look at. Here I have a to the 3rd times a to the 2nd times b to the 3rd. Remember, you can only combine the exponents if the base is the same. So you'll notice that one of these bases is not the same. He doesn't get to be part of the party. He'll be in our final answer though. So we add these together to get a. Now you don't add the a's together. The a's stay the same. What you add is the exponents. So you get a to the 5th power times b to the 3rd. Okay? So the b didn't change, but the a exponent did. Same thing over here. I have 2 x's and I have 2 y's. There's multiplying between them, so this should work out easily. Remember, this is x to the 1st. You got to remember that. You don't see a number there, it's just like to the 1st. So you end up with x to the 5th, because you add the exponents, and you end up with y to the 9th, okay? And that's your final answer, okay? You needed to see this with the numbers in order to see that it works with variables, because that's where we're going to be using this mostly on, okay? So let us work some examples now that might have numbers in them. So for instance, here we have some examples that contain numbers, such as, move my leg, such as -2 x squared times 4 x to the 5th. What you do is you multiply the numbers. Do y'all remember what the number in the front is called, by the way? If a number is in front of x, I don't remember if I think we went over this, but I believe it would be called a coefficient. You should remember this. It's called a coefficient, that number in front of x. So you multiply the coefficients together, and you would end up with -8x, add the exponents to the 7th power. Okay? Over here, you can pause the video and see if you can get this right. And you can be like, yes, I got it right. Or you can be like, man, I got a question about this. So either way, -4 times 3 is going to be 12. You have c, add the exponents, and you get 10. C to the 10th power. And that's your answer. Okay? Let's flip over the page to look at some more examples. Okay. Things about to get really interesting. For example 2, we are going to be looking at these 2 examples and a few others. You'll notice that it looks a little weird. Here we have a 2 to the 3rd, parenthesis to the 2nd. How would I begin to work that out? Okay? Well, think about this. Let's start on the outside. This to the 2nd power is saying that I have 2 copies of whatever's inside the parentheses. So it's like saying I have 2 to the 3rd power times 2 to the 3rd power. Do you see that? This square is saying I have 2 copies of whatever's inside the parentheses. Now this is saying that I have 3 2's, and this is saying I have 3 2's. How many 2's do I have total? Well, that would be 6. Remember, following the rule, you can just add the exponents together? Well, let me show you something simpler. You don't have to break it down to this and then add. Isn't 2 times 3 6? It is, and that is the pattern. I know we just done one. It might not be easy to see, but that's how it works. You could work this out, and you would get, if you worked out 2 to the 3rd, that would be, what would that be? Work it out. 2 to the 3rd is 8, and then 8 squared would be 64. Okay, that equals 64. Well, go and work out, what's 2 to the 6? Work it out. I bet you it's 64. Okay? So work that out. Next, we have this. We're just going to multiply, like I said. So now you end up with 7 to the 12th power. Okay? That becomes 7 to the 12th power because you just multiply. One way to remember this easily is remember that when a number is touching a parenthesis, we multiply. So since the exponents are up here floating in the air together and there's a parenthesis between them, we just multiply the exponents. Okay? Let's move on to some more examples with variables. Once again, very simple stuff. Just multiply the exponents. So now you end up with c to the 15th power. Over here you end up with x to the 55th power. Okay? Make sure you write down any questions you might have. And now let's move on to division. Woohoo, division. For example 3, we'll be looking at division. Now I want you to think back. Don't look at these examples, but think back to the examples on the last page. The ones where we were multiplying the bases. When we had to multiply the bases, we added the exponents. When we multiply the bases, we just add the exponents, okay? Now I'm dividing. What do you think we're going to do when we divide the bases? Think about that. We multiply the bases, we add the exponents. So we divide the bases and we do what to the exponents? Well, you're going to end up subtracting. And you could write this out. You could say I have 3 times 3 times 3. That's an ugly looking 3. 3, 3. That's 5 of them. 3, 3. Okay, so that should be 7 of them. And you could write this out so that you have 3, 3, 3, 3. And they could basically cancel each other out. You can go say, okay, those cancel out, those cancel out, those cancel out, those cancel out. So I'm left with just 3 3s, okay? So I get 3 to the 3rd power, okay? Now I just want to remind you that while we're doing this work, we are writing using exponents, but if you were told to actually simplify this, you would have to work this out, okay? So I just want to make sure that you know that. So, you just, let me fix that, just that again. All right, so you just subtract. That's the easy way to do that. Let's look at this one. So I really do not feel like writing out x 20 times and then x 16 times and then finding out how many times does each one cancel each other out. Instead, let's just subtract the exponents. So we're left with x, you can put the equal to. This equals x to the 4th power, okay? So there we go, all right? Now we do need to look at some other examples, and these will make some great points right here. All right, take a look. Here we have one that includes some numbers and some variables, so let's take care of those. You say 12 divided by 4, which is equal to 3. That comes out with a whole number this time. And we have m to the 4th divided by m. Well, what would that be? Well, what is this m? What is its exponent? Its understood exponent is? Well, no. All right, so if you subtract, you end up with m to the 3rd. There we go. And that's the answer. Final answer right there. Boom, boom, boom. Moving on. Now, next, I want you to notice something when we get here. Okay. Notice that when we did this, there was less exponents on the bottom. Like if you look up at this first one, we have a bigger exponent on the top, bigger exponent on the top, bigger exponent on the top. Now over in this example, you'll notice that we have a few of them have bigger exponents on the top, some have bigger on the bottom. If they are bigger on the bottom, the variable with its exponent will remain on the bottom, okay? So when we do this, you could say, well, 8 over 20, does that reduce? I don't think that comes out to a whole number. I think it's a fraction. It's going to reduce. Well, I know the GCF for these fractions would be, if I had, you can cover it up just to look at it like that at first. So I got 8 20ths. What does that reduce to? Well, 4 goes into both of them. 4 goes into that 2 times. And that 4 goes into that 5 times, so there we got that fraction. Okay, now here I have x the 2nd and the 4th. If you were to subtract these, you could say be negative. Anyways, we'll just do it like this for right now. I'm going to show you different examples, and we'll do it in class also. But this would come out if you had 2 minus 4. That would be negative 2. Now, when you have a negative exponent, what you do is you can get rid of the negative so long as you put it in the denominator. So you end up with x to the 2nd, and it stays in the denominator. See, unlike the other ones that we did where they got to come out of the fraction, this guy doesn't because there's more x's on the bottom. So if you would like to write this all out and cancel out, where would the x's be left? On the bottom. Now the y's, since there are more y's in the numerator, where will the y's be left? On the top. So when you get done subtracting this, you have y to the third. So you have 2y to the third divided by 5x to the second. Okay? I expect a lot of you to probably ask questions about this, and we'll go over this more in class. But, put a question mark by it and ask in class. I challenge you to be the first one when we're going through this to ask about this. See if you don't understand this, see if you can be the first one to ask. I challenge you to do this, especially you students who are sometimes afraid of asking questions. Okay? Last ones we're going to look at are these ones. And this makes a great example. What happens if I have b to the third and b to the third right there, okay? Got b to the third, b to the third. The exponents, so I could say 3 minus what? 3. That's going to cancel the whole thing out. The whole thing just disappears. And we're going to take a look at that. So you end up with b. Sorry, you don't end up with b. You end up with, that's gone. The b's are just all gone. And you end up with c to the fourth divided by c to the third. So that's just going to be c to the first. So you just write down c. So the b's are all gone. Whoosh, disappeared. Okay? Now this is a negative exponent, and this is a real easy problem to do. I mentioned it up there on example 3D, the one right above this one. But when you have a negative exponent, it will want you to get rid of the negative exponent at times. And at times we're going to go back and forth. We might have it under the denominator and it says write without a fraction, and you'll go back and forth. So we're going to go over some examples like this in class because I know this will be kind of it'll just blow your mind. But if you have a negative exponent, you can write that as a positive exponent if you put it in the denominator. So you instead of putting it over 1, you put it under 1. You put 1 there, put the dividing bar, put x to the fourth, and make sure x is now positive. Make sure the exponent is now positive, okay? So that's pretty much it. I expect a lot of questions in this section, so I will be impressed with the students who ask questions. So like I said, I challenge you to be the students that ask questions about the stuff that you don't understand, because I guarantee you the majority of students are going to have at least 1 to 5 questions in this section. Okay? See you in class. Bye-bye.